This is Manda Arpita. Today we'll be going to see about the binary search program. Here I have the command line which is hash include iostream. This is to include the header files, and I'm including the standard library.h file also. I have a max size which has been defined to be 5, and I'm using the namespace std over here. From here my main program starts. Here I say int a of max. So I am declaring an array for the max value which has been declared over here at the top. This max value is 5, so the maximum limit of a in the array will be 5. So here I have two function protocols. One is the binary search, which is an int method, and the second one is a selection sort. When we have a array of elements, the first thing what we are actually doing in a binary searching is we are searching for the element where it is present in the array. Before searching, the first condition will be sorting. So in this method, first we will be doing sorting, and then we'll go for the binary search method. The concept of binary search will be explained in the further assessments. Here I have my main program, and I've declared an integer variable I, and I am saying cout enter max value. The max over here is the same max over here, so we'll be taking 5 values of in the array as the input. And here I run the loop for I is equal to 0, I less than max, and I plus plus for max number of times, and I insert all the elements into a of I for these many number of times in the loop. So once when I'm done with that, I end the statement. Here I have another statement which runs infinitely, and which asks the user to press 1 for binary search to exit the loop. What actually happens is the user enters a switch case over here. When he presses 1, he'll enter the case 1. When he presses 2, he'll enter the case 2. So over here, in case 1, if he selects the binary search thing, he will be going to the selection sort function first. Then he will be going to the binary search function. So here I have a selection sort function, and here I have the binary search function. If it is exit, you are going to come out of the loop, and if you enter some other choice other than 1 and 2, you are going to display something like sorry, you've entered a currently unavailable status. So let us look at the selection sort. Selection sort is first sorting the array, like this is going to be your array, and you are going to say some elements 0, 1, 2, 3. What actually happens is the first element checks with the second element, and if this element if second element is less than first element, then these two swap. So this is how we sort the entire array, and this code shows here. So if you can see this part of the program, it says if a of j is less than a of minimum, then min is equal to j, and I'm swapping both of them. So here you have a sorted array. So next on the screen there will be a sorted array which is getting printed for you. Once the sorted array is printed, now you are ready to binary search. So the concept of binary search is that imagine that you have array of elements. So instead of searching each and every element, you have a small technique where you can avoid a consuming time process. So you are going to say start is here, end is here, and there is some mid value. This mid value can be calculated by start plus end by 2. So you first check the middle element, whether you find the element there or not. If you don't find the element over here in the mid part, then what I am going to do is so the first case is mid. So the block before this is mid minus 1, and the block after this is mid plus 1, whereas this block is mid. So if this number is not equal to the number I am searching, let me imagine that there is 24. If this number is not 24, if the number is 42, this number should either be less than this number or greater than this number. So I check either this side or this side. To go this side, I again change the limits of start and end. Here start will be the same, end will be my mid minus 1, and I am going to calculate mid based on the start plus end by 2. And here also, if this side is going to be my case, mid plus 1 is going to be my start, and the end is going to be the end only, and I'm going to calculate the middle using the formula. So now let us look at the function over here for binary search. Here I said int is equal to 0 and r is equal to max minus 1. So here I have a key which is calculating the values, And first I ask the user enter the element that you want to search for. Whatever the element is entered by the user is saved in the value key. And the other condition is that, so if your start is here, your end is here, you can perform your calculation. But if once your start exceeds this end limit, then it means your array is completed, searching is completed, and you can finally say that no element is present in it. So if this condition is true, then we are entering the loop. And as I told, for mid we have the formula low plus high by 2. This is a formula which I told you. And a of mid is equal to key. This is the first condition. If it is equal, then I am going to display this at this position the value is there. If it is not there, I am going to check it the less than value. Or else the last condition is a of mid will be greater than key. This is going to be my last case. So I check it for that. So this is how it goes, and finally the array is printed. Now let us see how the output looks like for the following program. So this is the same program which I have explained you till now, the binary search program. So let us run the program and see. So here it is asking me to enter 5 elements. When I say 2, 6, 9, 8 and sorry, I clicked another number. For example, let me say my numbers in the element are 2, 3, 4, 5 and 6. This is the max limit, 5. And here it is asking me whether it is binary search or to exit. When I say it is binary search, the first thing it is doing is it is sorting the array 2, 3, 4, 5, 6. Okay, I've already given some sorted array. Okay, let us see how it searches. So when I say I need to search for 3, it says it is at the position 2. If you can notice over here, 2 is at position 1, 3 is at position 2. So now let me give an unsorted array. So I'm running the program again. My unsorted array will be 8, 1, 6, 7, 2. Okay, so when I binary search, look at it, 8, 1, 6, 7, 2 is becoming 1, 2, 6, 7, 8. So if I want to search for some number like 12, that number actually does not exist. So you can see something called as element is not found. Thanks for watching this tutorial.